Good morning, everyone. My name is Chinmay Tripathi. I'm Director of Cloud Engineering for McGraw-Hill. And today's talk is lesson learned from multi-year implementation of cloud governance automation. And we'll be talking about how we effectively manage cloud automation, operations with regards to security, networking, IAM controls, operating system hardening, and patching. And I'll be joined by Nathan Wallace, who is CEO and founder of Turbot. All right. So some of the lesson learned. And before we get into the lesson learned, a quick introduction on McGraw-Hill. McGraw-Hill is a learning science company. And our data scientists are constantly curating billions of data interactions, which are created by our students by interacting with our digital products. And they're trying to identify trends, patterns, and opportunities to improve learnings for individual learners, as well as helping our teachers to teach better. And we partner with over 14,000 authors and educators, including 50 Nobel laureates. On the technology scale, we have more than 80 dev teams, more than 100 AWS accounts, more than 10 Kubernetes clusters, and 4,000 EC2 instances. So how did we get to hundreds of AWS accounts? I think that is going to be the central theme of this talk, and how we manage operating in the cloud at this scale. So chances are you are in the cloud because you want agility, you want elasticity, you want auto scaling, and all that good stuff which cloud brings to you. Most of the organizations start small, and we did that too. You start with like a small POC, maybe migrating 1 or 2 applications from the data center into the cloud. You start with a small team, working on a shared goal, and the goal is to bring your stuff in the cloud. And eventually you are successful after a few weeks or months. You build a team, you build your pipeline, you build your services around it. Maybe you are using config management tools like Puppet, Salt, or Chef. And then you grow. You are now moving maybe 10 or 15 applications into the cloud. Now you go to the stage 2, which we call share house. What it means that you have multiple teams working on different projects in one single AWS account. And this model works as well for some time. And then inevitable happens where somebody makes a security group change, thinking they are doing it in a dev environment, but that security group is shared by a production application. Or maybe a routing table change, or maybe a NACL rule change, or maybe somebody updated the AMI and updated the Java version thinking, it's not going to impact everybody else, but that AMI is shared by other applications. So that model is also not working. So you need to separate your workload, the production workload, from your dev environment. And that brings us to the next stage, which is hosted service. And what it means, now you split your environment into dev, test, and prod kind of model, and you separate your workload, a production workload from your dev environment. And this is the model we think most of the organizations stay for a bit longer than the first 2 model. You could go on for like maybe 6 months or a year. But this is also not a scalable model, right? Now you're in the cloud. You have built a team, a centralized team. You can call it your cloud team or your DevOps engineers. They're getting comfortable. They are building your CI/CD pipelines, building services, EC2 infrastructure, all that good stuff cloud brings. They have the tribal knowledge. They have created a lot of services around it. But business demands more. Now you're not comparing yourself from data center time. You want more frequent releases. You want 10 releases a day. Now when you scale it to hundreds of services, how do you do that? This core team, which has been doing your pipelines and managing your workload in the cloud, cannot scale with the pace of innovation your business want. Business want more agility, bringing more value to the business. And we face the same issue. So we tried to solve it. We hired more people, But ultimately, we realized that this model is not scalable. And that brings us to the next stage. So we looked into this problem, and we thought, OK, maybe we'll let more developers and engineers give access to the cloud API, because ultimately, it's all in code. Developers can code their application. They can code infrastructure as well. But you wanted to ensure that the separation of duty is maintained. You need a lot of security controls. And we thought we could do that. So we started writing IAM policies, right? So that if a developer is working on few services, he's kind of separated from the other workload running in the cloud, right? And we tried to write the IAM policies. It doesn't work. And the reason for that is IAM policies are hard, right? And if that is all you're doing constantly, eventually, it just doesn't work, doesn't scale. You're doing back and forth, too many change control meetings, and it doesn't work, basically. So we looked into this. We needed a better solution. So we looked into the model of Amazon. Amazon doesn't build data center for every of their customers. They have a multi-tenant model. So what we did, we started to give accounts to each of their teams or the business units. And we ended up with hundreds of AWS accounts. So the benefit of that model was, now we have 2 pizza teams in one account, right? They may be running 4 or 5 services, 6 to 8 developers and engineers, and the blast radius is minimized now. An activity done in one account would not impact other accounts. So you have solved the problem of agility, the freedom, and now your pace of innovation is much faster, and which is what you need to do. You don't want to slow down your developers because of your security controls and operational controls and things like that. But you have solved one set of problems and traded it with another set of problems. And that brings us to the next slide. So when we looked into the overall footprint of us, we had issues in security, in cost management, networking, and DevOps pipeline. Things like, how do you replicate all your security best practices across hundreds of AWS accounts? How do you ensure that not all the services are enabled in every single account? You don't, if a team comes to you and asks for an account, and they just want to run serverless, maybe you don't need to give ECS access, or ACM access, or S3 access maybe. You want to restrict the services which is required in that particular account. So service whitelisting is very important. How do you ensure your cost doesn't go over the roof? So there has to be some kind of a budget enabled in each account. Maybe you need to create a certain key pair in every account by default so that the future automation is easy. Maybe you need to create service account later at some point. Or maybe you need to do user management. In security, you want to ensure all your AMIs are managed properly. Now you have your scale is so big, and you don't have your core DevOps team anymore. It is open across all your organization. So you need to have those security controls and policies and rules and regulation in which all these accounts can operate. All right. So that brings me to the next slide, and we will be talking about some of the lessons learned in the area of security. The first is root credential management. And I think at this point, everybody knows that using root credential is a bad practice. Nobody should do this, but I'll repeat it anyways. Make sure you are rotating your root credentials, root passwords, enable your MFA, enable your security questions, and don't allow any application to use the root keys in their pipelines. But here's one extra tip. To discourage people from using root, have your root credentials managed by 2 separate teams. And what we do is essentially have the password managed by one team and the MFA managed by another team. That way, they always have to coordinate and collaborate if you want to log into your AWS account as a root user. And of course, rotate your keys every few months. Service accounts. What we are trying to say here is, how many times it happens that you are in the middle of a big product release, and everything is going well, everybody excited, you run your pipeline job, and it doesn't work. The job fails. You look into the logs, and you find out that the credentials don't work anymore. So what happened? The user which owns the credential is no longer part of your organization. So good job expiring the credential, but you shouldn't have used that credential at the first place. So recommendation, use machinery access for machinery jobs. If you're running a pipeline or a release or deployments, use service accounts or machinery access like IAM roles to deploy your code, and not credentials which is tied to an individual users, because users are eventually going to leave. For individual users, use them for POC or for testing, troubleshooting, and stuff like that. The next is automated account configuration, and that is very important, especially when you're operating at a scale of hundreds of accounts and you have to provision these accounts all the time. You want to ensure all your security controls, your security policies are fully automated. Your VPC creation, your security groups, your user management, your access management, it should all be automated. And now we're going to talk about some of the security services which we have found very helpful in managing our cloud environment. So before I get into that, can I get a show of hand? How many of you use flow logs, CloudTrail, and GuardDuty? Okay, that's pretty good. So to those who don't, I'm a quick rundown on these services. Flow logs. How many times it happens that you are trying to log into an EC2 instance and you cannot log in, right? Happens with us all the time. It could be a problem in your network where you are operating in, could be a local issue, could be a routing issue, could be a firewall issue in your data center, could be an issue with security group on the EC2 instance, or could be an issue with your NACL, or could be a local issue on the EC2 instance itself. Maybe the user is not set up yet, or maybe the keys have not been created yet. Use flow logs, a great tool for network connectivity troubleshooting. Basically captures all the IP traffic metadata, including source IP address, destination, port, protocol, as well as whether the traffic was accepted or rejected. So great tool. We use it all the time, helps tremendously. But it is also a great security monitoring tool. So the challenge here is, how do you take all these logs and put to a centralized location where security teams can analyze these logs and create some analytics, or maybe integrate with CloudWatch events to send out some notification and take some actionable, create some actionable workflow. So you can use CloudWatch logs or S3 bucket and use Kinesis stream to maybe to send it to your SIM solution, where they get a single pane of glass and know what's happening across all of your hundreds of accounts. The next is CloudTrail, another great tool from Amazon. You are troubleshooting, maybe you are doing an RCA, something went wrong, a security group was deleted, nobody knows who did it, you're trying to find out. Enable CloudTrail, and it will tell you every single AWS API call made in every of your account, and who did it, what time was it done, what action was taken. Enables governance, compliance, and risk auditing tremendously in your account. So definitely a very important service to be enabled in all of your account. And the point here is, how do you do it at scale? So you have to have a process when you provision your account, all these basic services need to be enabled by default. At the same time, you have to ensure that nobody goes and changes it. Right? It's possible that you enable CloudTrail and somebody's trying to remove the traces of their activity. You should get an alert and maybe have an automated guardrail to correct that mistake. So detection and correction immediately is very, very important when you are managing hundreds of accounts. You cannot have, do it after 2 weeks or 3 weeks, because by then it's probably too late already. And that brings me to the third service, which is my personal favorite, and that is GuardDuty. This is relatively newer service from Amazon. So with Flowlog and CloudTrail, you have a lot of data. You have all the API calls, event logs, you have your network traffic. So security team is getting all these logs, and they are constantly analyzing it. And it's very easy for them to get overwhelmed. It's a lot of data. They can try, but it doesn't really work very well. In a sense, it's just too much information there. What do you do with it? How do you create your events? GuardDuty solves that problem tremendously. It is a threat detection service which is continuously analyzing all your VPC flow logs, all your CloudTrail events, and trying to do threat detection by analyzing these logs and finding any kind of malicious activity or potential threat in your account. Within the first week of enabling guard duty, we had some major successes. We found out many applications were still using root credentials within the very first week of enabling guard duty. The other day, we had an issue where we got an alert from guard duty that some user has just terminated 20 EC2 instances. We got the alert, we started looking into it, and we're like, this happens all the time, right? People go and spin up instances and infrastructure and terminate them. So what's the big deal, right? We started looking into it and found out the user had no business in that account. It was a mistake. He was supposed to work in a different account, but the keys got mixed up or whatever, but he landed in a different account and terminated the instances. So great tool for things like that. Your SSH port, it should never be open from internet. We get alerts from guard duty all the time. People make mistakes. Even though they know the best practices, sometimes they're in a hurry, they're troubleshooting something, they enable port 22 from internet, and next thing you know, the guard duty sends an alert that you are getting brute force attack. So great tool. If you have not checked it out, please do so. It's going to make your life very easy. Automated security response. And that brings me to the topic of automated guardrails. And what we are trying to say here is, if you as an organization have a policy to, let's say, encrypt all your S3 buckets, right? And you have all your best practices laid out. But now you have hundreds of people who are creating S3 buckets every day. And chances are that some of them will not encrypt their bucket. So what do? Do you get an alert and send an email, do follow-up meetings with your developers? Or you actually go and correct it? That kind of security response has to be automated. If an AMI is older than 6 months or maybe a year, do you want to allow your EC2 instances to spin up using that old AMI, or you want to stop everybody who is trying to use an old AMI? So that automated security response is a very critical aspect of managing cloud at scale. And that brings me to this slide, where you can see how we have our environment. This basically tells you how our environment looks like. In the middle, you have the guardrail automation. And this is the security rules and policies we have in a framework. And we use a tool called Turbot, which is always constantly monitoring all the accounts against our security policies and ensuring that the end desired state is always maintained with respect to, and I'll give you some examples. Things like cross-account access. Maybe you don't want cross-account access for S3 bucket or Lambda. You want versioning to be enabled all the time. You want to ensure your access logging policy is maintained on your S3 bucket, right? Your AMIs, you want to ensure that nobody spins up in a region which is not approved by your organization. So this guardrail is constantly working for us behind the scene. While we don't have to automate that, we don't have to worry about somebody creating an S3 bucket without encryption turned on. Or maybe somebody is using S3 bucket with no encryption in transit. On the left, we have the networking automation. All the accounts get provisioned using automation. All your VPCs, routing tables, subnets, security groups created by automation in a repeatable and consistent way. And of course, all of this is tied to your Active Directory so that you don't have to manage IAM users in your account. When you are managing hundreds of accounts, you can't do that. You have to tie it with some kind of a federation, and people just use that to get into any of the accounts they want. And we use the Turbot for access management and user management. It makes our life so easy. And we talked about VPC flow log and CloudTrail and guard duty. And the way we do all these logs need to be centralized. So we use CloudWatch logs and send all those CloudWatch logs grouped to a Kinesis stream and eventually stream it back to our SIEM solution. Now our security teams have a single pane of glass where they can have visibility into every single activity happening in all the accounts at one place. They don't need to log in into individual accounts. They have full visibility into everything. And that brings me to the next slide. Cost management. And I know this is a security conference, but it's still part of our lessons, and some of the aspects do belong to security. So right-sizing infrastructure is very critical. The cost in cloud can go over the roof if you're not careful, especially if you have hundreds of accounts. People can spin up 16 extra large instances and leave it running and forget about it. A week later or 2 weeks later, you might get the bill and you are like $10,000 over your budget. So right-sizing is very critical. To scale in and scale out when the demand goes up and down is very important to keep the cost down. But Amazon gives you an option to purchase reserved instances. And what it means is you commit to a certain instance users over 1 year or 3 year term, and Amazon gives you a 60, 70% discount. So use that. Some tips over there is go short term if you're not sure about your workload. You can go with 1 year if you're not, because this happens all the time in reInvent. People go to reInvent and come back, hey, Amazon has launched this new instance type, it's pretty cool, let's use that. They come back and spin up their infrastructure using the new instance type, and now you're paying double. You're paying for your reserved instances as well as on-demand pricing. So go with 1 year if you're not sure. By that way, you have an opportunity to correct your mistakes after 1 year, rather than wait, you're getting logged in into 3-year contract. And that brings us to some of the other cost-saving opportunities. Monitor for your unused resources. Things like volumes which are not associated with an EC2 instance anymore, and this happens all the time. People spin up EC2 infrastructure, terminate it, volumes get left behind. They spin up ELBs and then leave it running for months. They forget about it because next time they're going to use another ELB. Or your NAT gateways, or your snapshots. Individually, these don't cost a lot, but we were able to save hundreds of thousands of dollars by just automating our EC2 volumes removal. So it works like, and we use the guardrails as well for that. If a volume is not associated with an EC2 instance, you tag it, you wait for a week, take a snapshot, put it aside, and then remove the snapshot after 3 months or 6 months or whatever is your retention policy is. And same thing is with your gateways as well. They do cost money. Another tip, for your instances, your dev instances, your sandbox instances, or testing instances, which you don't use 24/7, shut them down. 8 p.m. to 8 a.m., maybe you want to shut them down, and by the time your developers come in, they can be up and running. Or during the weekends, or when there is no testing happening, your testing instances don't need to be up and running. You can use a service called Instance Scheduler by Amazon to automate that part for you. And that brings me to the networking aspect of managing your cloud environment. So now with CI/CD pipelines, infrastructure as code, developers are the king. And they can build your infrastructure. They can build your application. They can run code at scale and things like that. But developers are not network engineers. While VPC creation is a relatively easy task, you make an API call, your VPC is created, but there is a lot more goes into managing your network, especially if you're operating at hundreds of accounts level. You need to spend some time thinking about your network. Ensure that you are using some kind of a design principle. Things like how many availability zones you want to enable in every account. We recommend to use 3 because that gives you high availability, and if an availability zone goes down, you have some backup. But you have to have some kind of a consistent way of replicating this in all your accounts. So automate your VPC creation. Have a repeatable and consistent way. Make sure that naming conventions are followed, tagging is right. Because when you want to scale your network, and everybody is going to do that at some point, and I'll give you a story where it helps. Recently, we were to roll out Transit Gateway, and to those who don't know about this, it's a new service, relatively new service from Amazon. It allows you to unify all your networks. It makes it a one single network. Now you don't need to peer your account if you want high bandwidth. When you are making service-to-service calls between 2 networks, they can go over Transit Gateway as if they are sitting in one network. So we had to roll out our Transit Gateway. In the accounts where we had a consistent naming convention and tagging and consistent network design with regards to VPC names and subnets and availability zones and routing tables, We were able to roll it out within seconds without creating any impact to any application across hundreds of accounts. But the accounts which were older accounts, where things were done manually, hundreds of subnets, hundreds of route tables and stuff like that, it was absolutely a nightmare to update your route tables without impacting your application. So we ended up doing a lot of hand massaging and handcrafting scripts, manually verifying if the route tables are correct before and after and things like that. So it will pay you off in the long run if you are automating and giving it some thought when you're designing your network at scale. Things like, do you want to run your instances in the public subnet? We recommend not to. There is no reason for you to run instances in the public subnet. It improves your security posture if you run all your instances in the private subnet. And to that effect, we do two things. We deliberately create our public subnets with a smaller CIDR range. We don't give too many IPs, like Clash 27. With 32 IPs, you can't do much. Maybe you can run your ELBs and ALBs, and that's what it should be limited to, not run your EC2 instances. They should be running in the private subnet. And that brings me to the last topic in this networking aspect is the default VPCs. You don't want to use them. Eventually, you're going to run into various issues at some stage where there is a CIDR conflict. In fact, we had a story there a few weeks ago. We were trying to troubleshoot an application performance, and it had two services. One was running in its own network. The other service was running in its own network. And when service-to-service call was happening, it was slow. So from my point of view, it was an easy fix. Just peer them, right? But we couldn't because they were using default VPCs. So if you use default VPCs, you should not use the default VPCs. You are going to run into some kind of problem. And of course, ensure that VPC CIDRs don't overlap. You are going to run into serious issues if you let it happen. Eventually, when your services grow, they need to talk to each other. They need to make service-to-service calls, and it will be a problem too. Even to connect to your internal network, it will be an issue. And that brings to the DevOps practice. So a typical CI/CD workflow of DevOps, basically a developer checks in the code in version control, a CI server builds the code, creates an artifact, sends it to the Artifactory, from where you deploy your code. And CI/CD workflow for DevSecOps, basically, you want to inject some security controls in it. Things like pre-commit hook. Make sure your secrets and passwords are not making its way into your version control. So there is an opportunity to scan it before it goes in the version control. And if it goes there, have a periodic scanning of your version control to make sure the secrets and passwords are identified, rotated, and removed from the code. And once the code is in the artifact, your artifact is in the Artifactory, there is an opportunity to do some scanning of your images as well. But the important thing here is when you are running your services in your dev and production account, how many times it happens that you are trying to release your application, which has worked for months. All the same pipeline works in your non-prod environment, but it doesn't in production. And the reason is certain services which it depends on is not enabled. As I said earlier, we don't allow all the services in all the accounts. It depends upon the requirement. When we get the requirement, we provision it only for those services. So service whitelisting is important. So ensure that your production account and non-prod account matches with regard to every single security rule and policies. And that's why we say professionals practice like it's real. You don't work in your non-prod, which is different from production. Your security rules should be same in both the accounts. S3 and bucket encryption should be enabled in both the accounts. So we created an API which you can call from your pipeline before the production release and make sure your two accounts match with respect to every single service and your settings and configuration so that you don't get surprises later. And if there is differences, stop your pipeline, fix that first before you proceed with your pipeline. So that is very important aspect of DevSecOps to ensure your production accounts match with your non-prod. There is no reason to keep them different. AMIs. So With the infrastructure as code and microservices architecture, it's very easy to speed up your auto scaling. We recommend to rely less on config management at boot time. Do the heavy lifting in the AMI itself. Have some kind of an AMI pipeline, which builds your AMI with your favorite operating system. Test your AMI. Send a API call to your scanner, which scans it and sends the result to your security team, which can look into the result, approve it or reject it, depending upon their findings. And then you publish it to all of your accounts. And this is how it looks. So basically, you have the AMI repository where you are building all your AMIs. They get approved. And once they are approved, they are published to all your accounts. That way, everybody is using the newer AMIs. And we do this on 1st of every month. The AMIs get rotated and built. Your golden AMI, we call it base image, they get built every 1st of the month. And now teams have the opportunity to use this new and approved AMI into their code. But an important aspect of AMI management is also to deprecate your older AMIs. If you don't, then eventually you're going to have an AMI sprawl. You may end up with hundreds of AMIs, and it will be a nightmare to manage and patch them. So we recommend to have a process where older AMIs get disposed when they're not in use. Okay. Another aspect of AMI management is, while we recommend to rotate your AMIs every few days or weeks, whatever is your policy, have a backup solution. When something like Spectre or Meltdown happens, you want to have an ability to patch your when you need to. So bake your AMIs with your patching agent, your security agent, your monitoring agent, and any tools which your organization need to ensure that you have a way to patch it later if you need to. And with that, I would like to call upon Nathan to talk about the guardrails.
Thanks, Chinmay.
Thank you.
So I thought what I might do is talk a little bit about governance as the concept, sort of building on what Chinmay's done, where he's giving you a lot of detail about how to really implement that. And now try to ask what are the lessons learned for that and how can we bring those to our different organizations. The first thing I like to do when I think about governance is actually talk about or think about government. What do you expect from your government, right? And most people would generally agree, although we'll disagree on how big or small that government might be, we would generally agree that government should give us some level of protection from internal actors, external actors, right? Government should give us a set of shared services to make our life better. And government should give us the freedom to be able to live our lives and operate. And so when we think about cloud governance, I like to sort of come back to those principles of how are we protecting, how are we having services, and then how are we giving our application teams the freedom to operate. So the first thing we think about when we have an organization is, what are the rules and regulations we want to live by in our organization? Are we heavily regulated? Are we more focused on innovation and speed? Maybe you're the combination of both, the nirvana. But basically, you have to think about those rules and regulations. And if you think about most of the average enterprise and how they've worked over years, there's probably 1,000 policy documents spread around the organization. There's someone called Joe in the networking team who happens to know how to name every subnet as it gets created. You have a whole bunch of enterprise knowledge, scripts, people, processes that have established how that works over time. Now the challenge is, as you move to cloud, you've got to work out how you're going to make that work at scale and speed of cloud. So I like to think about the 10-minute server as a way to challenge ourselves with that thought. How do I get from 0 to a full server I can log into in 10 minutes in a way that we can all sit around a table in front of a CIO and agree that that's an official valid server? So Chinmay spoke about the importance of AMI build pipelines, patching schedules, the way to do authentication and stuff into those servers. But if you think about breaking up that process, what does it mean to have that server? We have to have a network we agree on that's valid. We have to have security group rules we're happy with. We have to know where we're deploying to. We have to have a built-in image we're happy with. We have to be able to launch that of the correct size, get that running, and have a user actually log in and use it, or have it be part of a service meaningfully within that short period. Now, if we haven't defined every aspect of naming servers and automated them, the networking, the different parts of that, if every one of those decisions isn't defined in a rule, we cannot automate it. So one of the huge challenges as you go to real high at-scale governance is just having the rules defined. So you typically start with a standard set of rules or regulations, like best practices that are out there, and that's a great place to start. But you will quickly balloon to hundreds and thousands of policies. I'm not kidding, thousands of policies, right? How do you name things? What subnet sizes, servers? What do I want to do with EC2? How do you feel about external access or cross-account access to aliases of Lambda functions, right? That's the sort of coverage you have to start getting at scale in this environment. So you have to think about your rules and regulations. And more importantly, you've got to start to wonder, how am I going to set and manage those policies? And how am I going to handle exceptions in that environment? When you have hundreds of teams or hundreds of applications, you have to be able to do exceptions. S3 is always encrypted except for this one key case, right? Or these sorts of server sizes are appropriate except for these situations. So how do you manage exceptions at that sort of scale? And in addition, of course, why we love Amazon is they're bringing out 1,000 new features a year. So now your policy framework and your way of thinking about that governance has to be able to deal with that pace of change. We did not bring out 1,000 new features a year in the old data center, right? That's a whole new pace and challenge. We have to work out how we're going to handle as security professionals, right, in our enterprise and be prepared for that. The second part of that, of course, is setting up that infrastructure, those shared services that allow our teams to benefit from what we know. What a best practice security group, what's the best practice for configuration of our different encryption settings or the setup of different environments. We need to be able to know how we're going to do that at scale. How do we want to do identity repeatedly? So we have to have a method to be able to define those parts and make sure we're feeling comfortable about those services moving people faster. The big change, of course, as you move to cloud is that application teams suddenly have the power. Right? Traditionally, our infrastructure teams had the power in the environment. They could make the decisions, they owned the budget. Now application teams are actually more in charge about when servers are deployed, when they happen, how things change. That change of power balance means we have to work out how to handle, wrap, and respond to them. We have to put them in guardrails. We can't put them behind a gate. The other thing that happens when you do that, of course, is you move from a world of support, please start a server for me, to a world of help. I want to start a server, how can I do that? And we have to work out how to combine security or bake security into those processes, because if we kill that 10-minute server, we've killed the agility of the cloud. If we prevent people from creating a Lambda function, which includes creating an IAM role, we're killing the agility of the cloud. So we have to think about how our security is going to enable that agility and work with it at that speed, or we've become the block in the organization, right? Generally in security, we're cool to say no, but we don't really want to be the block. So that's where we come to real-time guardrails, the ability to protect these services and capabilities and respond in real time. When people are creating these capabilities all the time, whether it's using the console or Terraform, whatever they're doing, we need to be able to fix it immediately. Nothing else will get us there. If we want to say, I have to review everything before you publish it, we became the block. And by the way, your life sucks, right? Because you're spending your whole time reviewing JSON documents and things for people, and you just become the bottleneck all the time. Instead, what we want to think about is what is the framework of policies and regulations we care about. You can use SQS as much as you like. Just don't do cross-account access, right? Lambda's fine with IAM roles provided within an appropriate boundary for how you're doing it. Using EC2 is great, but it must be inside a VPC that's private, and it must be of such and such size. So long as we have those rules, we can give the business the freedom. And we're not arguing anymore about, is it a good idea to do this? We're basically saying, hey, so long as you're patched and you're not putting us at risk, go nuts, run 1,000 servers. You're meeting my requirement, right? And then we can let them make more of their own decisions in how they want to run with that. As you move to software-defined infrastructure, you need software-defined operations. You need software-defined security. Nothing else is going to keep up. We've given up our custom data centers to move to the cloud for the agility, consistency, et cetera, that provides. We have to now start wrestling with the idea that we've got to give up custom processes, custom scripts, and a bunch of hacks to cover the security and process of that, and think about how we're going to define those operations in a secure software-based framework that can act in real time. That's what governance at cloud speed and cloud scale looks like. It's a software problem. Once we get that right, we can actually give the people the freedom they needed, which was the whole point of why we existed in the first place. Why are we doing this? Application teams need the freedom to use these services. That freedom gives the business the agility to move, the ability to innovate, etc. That's what our goal is. Give them freedom while keeping them protected and accelerating them through services. So as we think about all these security decisions, we have to keep in mind that's ultimately where we want to get to. And how can we automate those decisions through the automated response, the governance, appropriate boundaries around people. That's not about an opinion about how it should work, but it's about the facts of what must happen. And you know you'll win if it gets escalated up. Right? And then there's things that should happen, which is make them faster. So with that, I thought I'd give you a quick look at what governance can look like when you move at that sort of scale and automation. So at McGraw-Hill, they've used Turbot for a while. And what they do there is basically have Turbot running inside their VPC in their environment. And it provides a model for identity, for access across the accounts, as Chinmay said, restricting services for different teams. So each user would log into Turbot, and they see the handful of Amazon accounts they have access to. The permissions in those accounts are actually simplified down to standard levels like admin, owner, operator, read-only, etc. And that's per service as well. S3 operator, EC2 metadata. You need standard language for that type of IAM, or you get crushed at scale. So they have that ability. But the second thing we want is basically the chance for those developers to actually just use those services with freedom. Use the Amazon console, use Terraform, use CloudFormation, whatever they might like. So I'm just going to do the simple bucket creation thing. Everyone likes talking about buckets because we understand them. So we want to give people the freedom to be able to do that sort of stuff. But what's interesting now is what happens next. So in the next 10 seconds, assuming the demo gods smile on me today, what should happen is Turbot will detect that bucket, automatically record that change in the CMDB along with who did it, test it against the policy posture for the organization, and then automatically remediate any problems it's found. What that means is we can now give our junior developers the ability to work without fear they're making mistakes or leaving us vulnerable, and we can speed up our senior developers so they don't have to worry about this anymore. So let's see what happened. So if I come into that bucket that I just created, you can see it's already turned on the versioning and it's set the tags, right? And it's moving through the different things it needed to do. Stuff like the tags includes rules like the cost center and stuff, context, right, from your organization for this one account. So those things have been automatically fixed in that environment already. Maybe the default encryption will come through as well. Let's see what happens. So back in Turbot, we can see the buckets got created. And we can see a couple of things going on. First, Turbot's tracked in the CMDB all the details about that bucket. It started to standardize some of the information like tagging, which helps once you get to a multi-platform world and you want sort of things working across different environments. Right, so we have that tracking in the CMDB. Below, you can see that it's recorded who created it. It was me with a pretty picture of me behind a pretzel. And then coming up and you have a bunch of the alarms that were raised. Versioning wasn't correct. Default encryption wasn't on. It then automatically remediated those issues and closed the alarms. That's a 5-second ticket close. So that's the sort of automation you want through hundreds of services. We have like 1,700 policies like that moving through different services in the environment. That's what it looks like at scale. Now, if we go into one of these, we can see this bucket's actually not approved. Turbot tells us why. It actually says it's in an unapproved region. I mean, you want to prevent everything you can. We do extensive work to prevent things in IAM. But there's a bunch of things you just can't prevent. Right? And this is just an example of when you may not be able to, although, of course, there's rules here you could. So an unapproved region, it's raised an alarm and said, okay, this one's unapproved. Let's look over here at policies. Controls are what gives us alarms in the state of the environment, but they're based on policies. As I said, we need a whole suite of policies in our environment for what's valid, which regions are allowed, which is encrypted, naming standards, etc. So if we look at the policies here, we can see something like what is the approved regions. And in this case, we're saying, hey, US regions are valid for buckets. Now in Turbot, the policy engine, the way that works is it comes down hierarchically. You can set a rule at the top, I want to only use US for all the buckets in all of my accounts. And that will be true now and into the future for every new thing. But what you often need to do is start to set exceptions, because maybe this one bucket's actually okay that it's in Ireland. So you can create an exception to say, well, actually this one I'll let it live in Europe, and this is an exception that beats a must rule from above. Recommended rules, you can let teams beat any time. Must rules, they require permission to do. And we can just save that exception. As soon as we do that, Turbot now knows about that exception, and it will re-review that policy, the control, to say, is it approved? So if we go back to the control, we can see it's flipped to an OK state. This is now an approved. This bucket is now approved to live in that region. In general, those simple policies give us the power we need for exceptions and stuff like that, and we try to keep that language very, very simple. What's cool is, though, you need to be able to see all the exceptions in your environment. Like I said, you end up with a lot of policies. So if we come up here, we can actually see a list of all the exceptions we've granted around bucket regions. If you're trying to manage a security team about all the exceptions you've granted in that environment, you don't want them hard-coded in JSON in 1,000 locations. What you want is a simple place to be able to see those decisions, have them expire, set rules around those things. Now, sometimes you want to get more fancy in your rules and decide that, okay, it might be okay to have a bucket in Europe if the tags are such and such. People do really, really crazy things when you get to hundreds of accounts and scale. So what you want there is stuff that gets even more powerful about the decisions. So we call these calculated policies. Now in Turbot, because you've got all that information automatically discovered into the CMDB, you can actually search that as part of a policy decision. So here we can do a quick search for for this bucket. Turbot has normalized some information like the tags. That's a GraphQL query against the CMDB, and it's found all the tags for that bucket. And then we can start to say, with that information there, now what do I want to do with that? I'm just going to grab a quick code snippet here. So that's some templating language, just some Ginger 2 if you're into that sort of thing. Right, and what it's doing then is it's saying, based on the information context for this one bucket and its tags, using this template, we can make a decision about what we want this policy value to be. You could look at the name of the bucket. Does it have a correct prefix? Tagging, whatever you want. It actually doesn't even matter. Right, and then that policy gets calculated there for that one bucket and goes along from there. So we can then just save that policy as we did before. Turbot's now going away in the background and calculating that policy for us and determining then the state of the control for that bucket. Now, if you have 1,000 buckets under that policy, it will recalculate all of them individually and contextually. Right, so again, you're now thinking in policy posture, rules across your environment. You're not thinking about small exceptions in text files in 1,000 different locations once you get to that type of scale. Now in the CMDB, we've recorded the information about this bucket and we have it here. And we actually put that in a context in Turbot. So we can see all the different controls here for this one bucket. So some of the standard controls you might want to think about in your environment is stuff like active. Should this still exist at this time? Right, and you might set a rule like in a sandbox account, all resources should be no older than 60 days, just to stop people running pseudo production in there, right? Or things like, is it approved to exist here? Is default encryption on? You can go nuts. We have many, many, many of those sorts of things. Now, if you roll up in Turbot, you can see controls here across the whole region, divided down by the different resource types, right, and the state of different things. We can go up to the account and see our summary of our controls there, and we can keep going to see across different platforms, across different environments, and all that sort of stuff. If we sort our alerts here, we can see actually the top one is our CIS controls in this environment, and now we can start to drill down and see information about CIS for our account. Turbot organizes these hierarchically as well, and these, by the way, happen in real time. You don't want to report you run once a month or you get the results much later. You want to see how it changes all the time. You change one thing, it happens real time in Turbot. If we drill into something like logging here, we can see different stuff, like for example, is the flow logging enabled? Right, and then per VPC, we can actually see the rules around that. So you can see that control for each target resource in the environment. See the state of it over time, how it's changed, if it became compliant, became non-compliant, we have all of that history information. Now, one of the things that's interesting is once you get to this scale of automation, and like I said, you will hit hundreds and hundreds of policies. It's a fact, and it gets hard to manage. What you need to do is start organizing that information very carefully. What are the names of your policies? What's the architecture of your approved, active, configured, data protection, standard names and structures through all of that. So you have a language to talk about. Otherwise, you're buried in minutiae. The other thing you need to do is start to categorize that stuff. So in Turbot, what we've learned over the years, we started with scripts, we've gradually built out. We now categorize everything. So we have a my bucket, which is of type AWS S3 bucket, and is of the category storage container. Right, now you can imagine as you go across other clouds or other environments how that starts to group things into categories or information. Same for controls. CIS is not only a benchmark for AWS, but there's benchmarks for Linux, other providers, other tools out there, and those are categorized by CIS into a control framework. So we can come in Turbot now and view our CIS report by the controls, which is now a cross-platform and full stack view of the control framework. So we can see different things there, and then we can start to divide it up. So we can say, hey, show it to me by the control category. Right, we can drill down into different areas and cut it in different ways, right? So now we're in that maintenance or section 6. And then we could say, hey, show it to me by resource category. So here's section 6 broken up by the type of resource. And that gives you a lot of insight to what's happening in the environment, the ability to target your quick wins, the different capabilities you want. We spoke about permissions before and the importance of that as part of the setup or management of the environment. So Turbot provides a permission model, which is what McGraw-Hill uses at scale across their environment. They use it for Linux as well, actually. So Linux level authentication as well as the accounts. Now, what's cool about this model is it actually follows the hierarchy again. So we can grant a permission to a user, and that's a straight up search of our directory. We can choose which permissions to grant. This is a simplified list. Like, we track 3,500 Amazon permissions at this point, so if you're really trying to do that at scale, I highly encourage you to go to a standard language around how you want to do them. And it's basically then you want to grant things like simpler, smaller groups of it, like for example, AWS read-only, S3 read-only. We support expiration of those sorts of grants, so you can say, okay, you get read-only on that for the next 6 hours, right? And then that will automatically expire. That's really important when you want to start to have models like security group. Your security team, you might want to give them access at the top level across hundreds of Amazon accounts for AWS metadata access. For us, metadata means no reading of data, right? Just seeing the resources. Metadata, read-only, operator, admin, owner. Standardize that stuff out, right? So once you give people like that access for metadata, they can see the environment move through it. Then you might say, okay, you need admin on a temporary basis to be able to troubleshoot something or fix things, so you use those automatic expirations. We also, by the way, do temporary elevation if you're into the really, really hardcore stuff around that. So that sort of permission model gives you a lot of flexibility. For your CMDB, you want to be able to do things like search, be able to find the different resources in the environment, or search by details, like for example, I want to see everything in my environment that's from the sales department. You also want to be able to run queries across your whole environment, for example, to be able to use an API to start getting stats out, running extra reports, going nuts, right, with that sort of thing. That's what software-based cloud governance looks like. It doesn't look like a bunch of small scripts in different places you've got to manage by hand. Now, the last thing I'll mention is we've started to understand that we started a lot with AWS stuff, S3, moved to EC2. Governance really is such a broad topic. With the companies we work with, we're finding that they're struggling with governance across their internal domain name servers, certificate expirations, a little dummy example here. There are hundreds of problems where we're trying to work out how to do this automated governance at scale across our pipeline tools, our external SaaS providers, et cetera. So we've started to think about that as something now that's customizable and extensible. So this is an example of a custom policy. We have a simple CLI tool, which I'd be happy to talk about another time, that developed this. But basically, all the policies and stuff are defined using very simple JSON schema language definitions. And then they appear in the policy engine, so you get the hierarchy, you get the calculate policies, all that sort of stuff, the control framework, the slicing and dicing, the reporting. And it gives you a way to start thinking about these scripts beyond deployed Lambda. You have a Lambda-style code, which then is automatically deployed, run multi-region, high availability, all the logs are sort of centralized in. So it takes that governance to a whole different level. And then your users can use those like they do any other policies with the validation and stuff in the UI to give them access to that. So if we change the certificate warning period to 365 days for the AWS Amazon thing, we'll see, I think they've got about 174 days left, right? So they have time. But then the space you can go to for this type of governance, the sorts of rules you can write for this type of automated governance is limitless. And that's the future of security. Coming up with our rules, defining those consistently with good names, and then running them in real time in an environment where application teams have the power and our service providers adding thousands of features a year. And that's why what we say is that, in effect, we have to start to accept that movement from a world of like software-defined, as we move to that software-defined infrastructure, we have to start moving to that software-defined operations. When we do that, the speed of our organization is unparalleled. Our cloud teams move faster because they've got automation. Our application teams move faster because they've got services to build on. We're safer than ever before. I mean, can you imagine saying every data storage was encrypted in your internal data center? That's now an automation away, right? We're better off than we ever have been. We're making it more accessible. Our junior developers can do more stuff because we're not afraid of the mistakes they might make. And we're more productive because we don't have to spend our time reviewing JSON or reviewing things. Once we've set our posture in place for the first application, the first account, it's guaranteed for the second one. We don't have to review each thing by hand anymore. What we do now is when people do something crazy and come to us and say, I need an exception, they were blocked from the start and now they're asking for permission. The traditional model is they go crazy, do a heap of stuff, and then come at the end for a review before production, and now we're blocking them, right? Automated guardrails running in dev and prod consistently change that relationship and change the structure of it from one of, fix this for me, you have to do this, to one of, help me solve this problem, help me get this service going in my environment. And that's where you see that change of relationship happen, is you start to have automation of all the basic stuff. So, Chinmay was able to talk today about so much stuff they've done with pipelining and building all those capabilities, and we're excited about that because we feel like we were able to enable that by doing so many of those basic standard things that organizations have to do over and over beneath that. Automating the setting up of those guard duties, automating the setting up of those flow logs, that's all just standard stuff that every organization does. So they start to, I wonder, why would we do it by hand? And that change of relationship happens once you have that security, automation, and monitoring of the underlying layer. You can give freedom to your application teams to use those services. They can work in a relationship with the cloud team to move faster. If they want to try a new service, you can create an exception for it in one account. Let them learn, innovate together, right? And work out how to do it, and then automate more of that stuff. And then others can use it. So you're starting to turn those standards into things you're gradually automating and improving over time. So anyway, thank you so much for your time listening to us today. We're super excited to talk about this topic. So if you have any questions for Chinmay or myself, hit us up. We'll talk about it all day. And have a good rest of the show.